All three of those things that I just showed you have one thing in common. But what is that? Well, they're all examples of sound. As most of us know, sound travels in waves. But how exactly does that work? Sound waves often start with a vibration. In this video, the guitar player is vibrating the strings of the guitar to form standing waves. Sound waves move in a similar pattern, known as a longitudinal standing wave. And standing waves are made up of two parts. There are parts of the standing wave that don't move and parts that do. The parts of the standing wave that stay in place are called the nodes, and these remain in the center while the other parts of the wave, called the antinodes, oscillate up and down. The waves in the string then vibrate the wood, which pushes air molecules out through the hole of the guitar and produces sound. We can best observe this process by watching how a speaker works. The speaker moves back and forth to push air molecules in a way which creates the sound waves. The way that we perceive sound depends on a number of characteristics. The wavelength of a sound wave affects the pitch. When you hear a high-pitched noise, that's how you know that the sound waves have a smaller wavelength. Wavelength is inversely proportional to frequency, meaning that when wavelength increases, the frequency goes down. Frequency is measured in wave cycles per second, also known as hertz. Amplitude is also a big factor in sound. In terms of the wave, it measures the height of the wave from the midline to the crest. In terms of sound, it affects the volume. The greater the amplitude, the louder the sound. Keep in mind that none of these factors change the speed of sound. Sound constantly moves at 343 meters per second when it's at a temperature of 20 Celsius. In comparison, this speed is almost 30 times faster than the fastest man in the world, Usain Bolt, moves at a top speed of 12.27 meters per second. How's that for fast? After being produced, the sound waves must then travel through a medium. In this case it's air, but what you may not know is that sound actually travels faster in liquids and solids. Anyway, the waves move through the air and strike our eardrums, which then vibrate in response. The brain interprets the signals that the eardrums are sending as sound. And that's how sound works.